Hello, my name is Andrew Lake, and I teach math at Topeka West High School. And this video is going to show you how to find the perimeter of a polygon when it is created in a coordinate plane by a system of points. Um, for example, number one here. If you are given three ordered pairs, our goal is to be able to graph those three ordered pairs, connect them in order to make a polygon, and then find the perimeter of that polygon. So let's deal with the first piece of that, how to graph these. Now remember, these go in X, Y order. So to plot this first one, I would go over 2 from the origin and up 1. So this would be the point 2, 1. To plot my second one, I would go over 2 to the right and down 3 because that is a negative 3. And then to plot this last one, I would go left 1 because it's the x value is a negative 1 and down 3. And that would create this polygon with points 2, 1, 2, negative 3, and negative 1, negative 3. If you connect those points with a line, then what you should have is a right triangle. And we know that to find the perimeter of a right triangle or any polygon where it has many straight sides, all you have to do is add up the sides. The perimeter of any shape is the distance around that shape from point to point until you get back to the same point. So to do that for this triangle, uh, for the horizontal and for the vertical lines, you can just count and add them together. So for example, for this horizontal line here, from -1 to +2, I would just have to go over 3. From -3 up to +1, I would just have to go up 4. To find the last side here, you can use the distance formula, which hopefully you all covered last week, or because this is a right triangle, I could use the Pythagorean theorem. I'm going to go ahead and do both. So if I want to find, let's call this C, using the distance formula. The distance formula tells us that the distance between any 2 points is the square root of the difference between your x values squared plus the difference between your y values squared. And again, for these sets of problems, it doesn't matter which of these points I say is my first point and which is the second. So I'm just going to arbitrarily say that this is going to be my first point. So this would be x sub 1 and this would be y sub 1. And then I'm going to arbitrarily say that this is going to be my second point, x sub 2 and y sub 2. So to find the distance between these 2 points, so I can find the length of this diagonal line right here, I can't just count like I did for the horizontal or the vertical ones. I have to either use the distance formula or the Pythagorean theorem. If I plug these numbers into the distance formula, what we would get is the square root of x sub 2 is -1 minus x sub 1 is 2 squared plus my second y value is -3 and my first y value I called 1. And again, it won't matter if you switch those to get your final answer. So if we do that math using the order of operations, I'm going to do my parentheses first. -1 minus 2 is -3. -3 minus 1 is -4. And now when I'm squaring these, I'm multiplying them by themselves. And if you type this into your calculator to find it, you have to type it in as I've written here with the parentheses around it. Otherwise, you're going to get the wrong answer because your calculator treats that negative symbol as multiplying your answer by -1. So it will square the 3 first and then apply the negative, and we know that's not right. -3 times -3 should be +9. And -4 times -4 should be +16. And then that gives us 9 plus 16 is 25, and the square root of 25 is 5. So this distance right here is 5. The other way you could have found that is to use the Pythagorean theorem, in which case we would say this is a squared plus b squared is equal to c squared, and where a and b are your legs. For our problem, our legs are 3 and 4, and we want to find c squared. And then that would be 9 and 16. You'll notice that the work you end up doing is very similar. 9 plus 16 is 25. And then to get the c value by itself and get rid of the squared, I'm going to square root both sides, and the square root of 25 is 5. Notice that you get the same answer. So then the perimeter of this shape is going to be 3 plus 4 plus 5, or 12. All right, and so again, the idea here is you graph your points, you connect them to make lines. For the horizontal and the vertical lines, you can just count. For these diagonal lines, you cannot just count. That's the number one error I see, is people estimating what they think like the length of that diagonal is. That is not what you want to do. What you should do is use the distance formula and just pick your points, your endpoints for your diagonal, and plug those in for your 4 spots here. Or if you rather, you can use the Pythagorean theorem. And I'll show you in problem 2 what that looks like when you try another problem that has slightly more points. Okay, so for number 2 here, we're going to do the exact same thing. We're going to plot them, and then we're going to try to find the perimeter of the shape. So my first point here, I would plot by going left 3 and up 5. 1, 2, 3, 4, 5. So here's -3, 5. Second point, I would plot by going over 4, up 5. So here's 4, 5. My third point here, I would go over to the right 5, and then up 0. And then last point, I would go left 4 and up 0. So what you get here is a trapezoid. If we connect it, our goal then, after we have connected this and made our polygon, specifically a trapezoid in this case, we want to find the perimeter, which again is the distance around the object from point to point till you get back to the point you started counting from. For this problem, these 2 horizontal lines here, I can just count. From -3 to +4, I would go over 7. 1, 2, 3, 4, 5, 6, 7. From -4 to +5, I would go over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the only other thing I need to find the perimeter is to find these 2 sides. I'm going to go ahead and do one of them using the distance formula and one of them using the Pythagorean theorem technique. So let's do this first one using the distance formula. Again, when you use the distance formula, you're going to plug in to the difference between your x values squared plus the difference between your y values squared. It doesn't matter which you call which. So I'm going to call this my first point. So my first x will be 4, and my first y will be 5. I'm going to call this other endpoint of this diagonal my second point. So my second x value will be 2, and my second y value will be 0. So the distance between those points is going to be the square root of x sub 2 is 5, x sub 1 is 4, y sub 2 is 0, and y sub 1 is 5. All right, and then if you subtract those, 5 minus 4 is 1, 0 minus 5 is -5. And if you type those into your calculator, or really you could just honestly do those in your head. 1 times 1 is 1, -5 times -5 is +25. And I actually prefer if you try to do those ahead, because again, if you try to do that in your calculator, you don't include those parentheses, it's going to tell you the answer is -25, and we know that's not right. -5 times itself is -5 times -5, and two negatives make a positive. In this case, we get 26, and now that is not a perfect square. So for that one, you probably will need to grab your calculator and type into it the square root of 26. So second square root 26. And to get that square root on the emulator that you all grabbed, it should be the blue button second, the x squared. You can see it's kind of tiny here, but that blue symbol, that square root symbol above the x squared, to access it, you just hit your blue button first, then you hit x squared. That'll give you the square root. Type in 26, and you'll get, let's round that to 5.1. So this is going to be approximately 5.1. All right, to find the perimeter over here, let me show you a trick that you can use. What you can do is make a right triangle to find this if you don't like the distance formula. I can say that if I go up 5 here and over 1, this is going to make a right angle here. And if I want to find the hypotenuse of this right triangle, again, I would just do a squared plus b squared is equal to c squared, where my legs are 5 and 1, which is 25 plus 1, which is 26. And we already found the square root of 26 is about 5.1. So the perimeter of this shape, if I add up all the sides, I'll have 7, 9, a 5.1, and another 5.1. So that'll get you a total of 5.1 plus 5.1 is 10.2, plus 9 is 19.2, plus 7 is 26.2. Yay. All right, so if you really get those lessons, I think these next ones should do just fine for you. You should be on the right track. I'm going to go ahead and have you try this next one. I already plotted it for you, and see if you can get the answers. I'll go ahead and fill in the coordinates for this one really quick. Uh, okay, so see if you can find the perimeter of this polygon with points 3, 3, 3, 9, 8, 4, 8, -4, -5, -4, -5, 3. Go ahead and pause your video right now and see if you can find that, and then I'll post the answer in 5, 4, 3, 2, 1. Okay, hopefully you got the answer 41.1. And how you can get that is, again, for these horizontal and vertical lines, you can just count. This should be 6, 8, 7, 13, and 8. To find this last one, the diagonal, you have to either use the distance formula or the Pythagorean theorem. In either case, you should get that this is 5 by 5, and you'll end up doing in the distance formula same thing. The distance between the x and y values is 5 and 5, which are squared is 25 plus 25, which is 50, and you take the square root of 50 and you get 7.1. If you add those all up together, you should get the final answer that the total distance around this shape is 41.1. Okay, let's do one more. Shin thinks the perimeter of the polygon below is 21.657 units. Find the polygon, or the perimeter of the polygon, to see if he's correct. Again, I'm going to urge you to pause the video now and see if you can get it. And then I'll post the answer in 5, 4, 3, 2. Okay, hopefully you got that Shin was correct. And here's the trick that you can use to solve a problem like this. When you notice there's symmetry here, you can just count that the top one here is 4, To find this diagonal, this time I decided to use the Pythagorean theorem. I said this is a 1 by 1, or the legs of this right triangle would be 1 and 1. You do 1 squared plus 1 squared will give us the hypotenuse then, c squared, which 1 squared plus 1 squared is 2. Square root of 2 is 1.4. And now here's the trick to save some time. I noticed that the other sides are also 4, and the other diagonals are also 1 by 1. So I just took these two, 4 and the square root of 2, and added it together, and then multiplied it by 4 so I can get all of the sides rather than working through every single one. In which case, you should get that the perimeter is 21.657. All right. Thank you all for listening. If you have any questions, you can leave them in the comments and I'll try to answer them, or, ask your math teacher. Have a good one.